In this lesson, we're going to talk about impulse. So this unit deals with collisions. And up until now, we've considered simple descriptions of motion. So something like a projectile that's in the air, but we don't talk about what happens when it hits the ground. When it hits the ground, that's a collision. So what are collisions? Collisions are when two objects have a short interaction that changes both of the objects' velocities. For example, if I have a tennis racket hitting a tennis ball. In slow motion, we could take a picture and it looks like this on the screen. So the ball is flattened just for a very short minute before it projects off of the racket. When you look at the collisions between the racket and the ball, we're going to look at two different variables. The force between the two objects, that's the force from the racket to the ball and from the ball to the racket, and the time that the collision takes place. So for a soccer ball, it's going to be similar to a racquetball. We're going to look at it in step by step. We have a foot starting to kick it right before it hits, and then it is compressing the ball slightly, and now the ball is moving to the right. The amount that the ball compresses will depend on the magnitude of the force of the foot. So that's your first variable. The force of the foot changes the amount of compression of the ball. And the amount of compression is going to affect how fast or far the ball goes. So the ball will go further if the force applied by the foot is larger or the force is applied over a longer time. A larger force extended over a short time is called an impulsive force. So when you kick a ball, that's an impulsive force. Examples would be when you hit a nail with a hammer or a bat on a baseball or anything that's a short time and a large force. So we can look at these forces on a graph, and this is the force on the y-axis and the time or the change. The time was graphed on the x-axis. In this case, because it's such a short time, we're using milliseconds or 10 to the negative 3 seconds, and our forces are in newtons. This is called a force versus time graph because force is on the y-axis, and that comes first when we describe the graph. So this is let's say we hit a ball and this is what our force looks like. It starts at 0 and then we begin contact with the ball. The force becomes the greatest in the middle and then it goes down again, and now the ball is moving to the right. So this area under this graph is going to give us the basically what the impulsive force does. And the larger the force, the taller the graph, the larger the area, and so the larger the effect of the force. Also, if we acted over a longer time, we would have a wider graph. So over a longer time, we'd have a larger area, and so a larger effect of the impulsive force. So the larger this area is under the graph, the bigger the effect of our collision. And the area under the graph has a special term, and it's called an impulse. It is abbreviated J. We'd think it's abbreviated I, but in physics we use I for current. So impulse is abbreviated with a capital J, and impulse is basically how much the force has an effect. So in these graphs, the area under the graph is the impulse. Other ways to explain the impulse, we can say first, impulse is the area under the curve for a force versus time graph. We also have a mathematical equation for impulse. And impulse, you can see, has an arrow above the J. That means it's a vector. It points the same direction as the force of impact. And that impulse is equal to the average force vector times the change in time. So the simple mathematical equation is to take this graph and simplify it to what's the average force. And that force times So whatever that force is times the time will give us the impulse. The units for impulse, you can see it's force times time, so it's going to be newtons times a second, or newton seconds. That's also can be written as kilogram meters per second. In the next lesson, you'll see why we choose to use kilogram meters per second. So let's do a problem. Fred is going to bounce a rubber ball on the floor. And here he is. The graph is going to show the force of the ball during the collision. So we have the force of the ball over time, and first nothing has happened, and then this is when the ball starts contact with the floor. It has an increased force and then a decreased force, and now it's starting to bounce back up. So this is the time we're concerned about. What is the impulse on the ball? So impulse is the area under the curve. So this is a simple triangle. We can use our equation for a triangle. 1/2 times height times base. It gives us 300 times 8 milliseconds, which is 8 times 10 to the negative third seconds. 1.2 newtons per Newton seconds equals 1.2 kilogram meters per second. Now, if I'm given that as our impulse, how can I find what the average force is on the ball? So we know we have this maximum force and our minimum force is 0 and it's over time. Well, the average force, we're going to go back to the math equation for impulse. So the average force times the time will give us the impulse. So we're going to go backwards because now we have the impulse and the time, and we can use that to find the average force. So our impulse equals our average force times time. Then we're going to divide both sides by 0.008, and we get our average force was 150 newtons.